Yeah, the screen. Yeah, the screen was paused, so I will show again. Pressing F10, we are going through the instructions one by one. Typically, the calculation consists of more than one CLC file, so you would like to see also what's happening inside the external CLC file. The first thing which you have to do is to tell Design Forms Builder where is the source code and open the CLS file. It can be done quite easily pointing the cursor on the load external CLC function and press F12. As you can see, the new window is opened in Code Editor, and the name here in the bottom corner is external CLS. So that's the file name of the external calculation. Now when I use F10, you can see that it breaks on the exception. I have some function which is called throw exception, which calls some non-existing function, which obviously cause an exception. So when I'm in debug mode, Design Forms automatically stops here and tell me, hey, something's wrong, there is some exception. I can continue pressing F10. So this is the function which throws the exception. I'm coming back here to the master CLC and finish the script. I have one more option to step into the function, into the inside code. It's very similar, but I'm pressing not F10 but F11. If I am able to step inside, then I step inside. That's the difference between F10 and F11. Here you can see that I step inside the function validate input of the external CLC. Then I continue with execution of the function itself. And at the end of the external CLC, we are getting to get output function, which is called automatically because we used this syntax to call external CLC. To just show the difference, now I will press F10, so we step over the function. Pressing F10 again will throw the exception, so Design Forms automatically stops here. Now I will press F11 and I step again inside the function. So you can choose if you are interested about the content of the function itself, or if you want to step over and keep the context in which you are currently. Very useful with debugging is something which is called Object Inspector. That's the window which can show you what's the content of variable, structured variable, object variable. When I click on this button, you can see the Object Inspector itself, which show me what's the content of variable E in this case. I see that's an external calculation, which has some functions, some variables. I can expand the variable G, which is graphics. I can see what is my font, my pen, and so on. So I can inspect any part of the external calculation. Similarly, I can open the input variable, which contains my font, my pen, which are some variables. Again, I see what is the content. Yeah. Table of variables is automatically updated according to the context in which I am. Yeah, so when I show this again, have a look that when I go inside external calculation, the table of variable is changed, because now in the current context there is no I don't know which were these two variables, but here there is just one variable, that's the input. I can open it, I see that there are my pen, my font, when I press F10 and continue, again the context is changed. I see variables of the external calculation itself. When I press F10, go over this instruction, I see that the graphics was changed from null to the graphics, and so on and so on. When I'm done with debugging, I can continue pressing F6 or F5. F5 will throw an exception, but this will finish the calculation. It in fact stop the debugger and go to the end of the calculation. Similarly is F6. The only difference is that it stops on exceptions. F6 is running with debugger to the end of calculation, so this throw an exception and stops on the instruction with throw that exception. I see something in chat. Nothing. Is there any question to debugger or object inspector, or any experience with that? We had some difficulties with Concrete Toolbox. The problem is that Concrete Toolbox is single-threaded DLL, which is not able to run in various threads. But I believe that most of issues were solved, and also calculations which use Concrete Toolbox should be running correctly under the debugger. So, once again, is there any question, the debugger or the object inspector? If not, we will proceed to the second topic of today's training, and that's the way how you can reuse, I will close these calculations, how you can reuse objects. In this particular case, font and pen, but it's clear that this functionality or this attitude can be used for any object, graphics, custom table, or whatever. I have made a very simple example which draws these graphics with simple text and a circle, and the only input from for the external calculation is a font and a pen. And now I would like to show you 3 ways how you can send these variables, these objects, to the external calculation, and in fact share them from the master to all levels of external calculations, all descendants. The first way how you can send these parameters to external calculations is use this variant of draw command, which send input structure to the external calculation using the standard technique which was created or developed some time ago at the beginning of this year, and which is recommended way how the external calculations should be called. How it works, very briefly, we create some structure which contain all inputs for the external calculation. The external calculation itself defines function validate input, which is used to validate and read the input. We read these parameters which comes from the master calculation and validate it. If we return true, everything's okay. If there is some error, some mistake, something is missing, or out of some borders, we can return false and say no, we are not able to use these parameters. In this case, I return true, and font and pen is read from the input. Then I simply use it in simple drawing, and the result, you can see the result here. Yeah. So that's the very standard way how you can pass parameters, object parameters, to external calculation. The second way, slightly more, let's say, complex or advanced, is used result holder. Result holder is something which is used mainly for calculations running from calc.exe. but you can use it also for these purposes. There is a pair of commands, save results and read results. Save results, save some value, user-defined value, anything what you want, to some place with specific key. You can see that I save this font under the key my font, and the place where I want to save it is defined by this switcher. I can save this result to the level of member, place or section, or combi. The only difference between these three places is the time of validity, or the, let's say, context of validity. Result saved to the combi is valid just on this specific combi. It means when, for example, a calculation is running from calc.exe and we go to the next combination, then this result is not reachable because it was saved, for example, at combi 0. Now we are working with combi 1, so we are not able to read it. When you save this to the section, you are able, or the result, the values, is accessible until you are on the same section. So, for example, you have 5 combinations. At the first of this combination you save something at the section level, so from each combination on this section you can read this result. And the highest level is the member, which as the switcher indicates, the result, the value is saved on the member level, so you are able to access it from any section, any combination which is processed on this member. In this particular case, we want to access these values from any place, any combination, so we save this on member level. This is in master calculation. In extern, we read it with read results command. We specify the result holder and the key. As you can see, the font and pen is correctly read and we are able to read it. The advantage comparing to first attitude is that this can be saved only once at the very high level, at the topmost master calculation, and then you can reuse it in any extern, any dependent calculation. So you don't have to pass parameters from one by one. You don't have to take care about this. You simply save these values at the very beginning and then just read it. This is a very simple way how you can, for example, share fonts and pens, for example, maybe colors and stuff like that. The last, and I have to say not recommended attitude, but also possible, is to override save result and read result functions and touch the I/O structure directly. You can use set command, which set the value under a specific key. Save results do exactly the same thing, but at the specific place. Here you save these values directly to I/O structure, and you have no guarantee that it will not collide with someone else's calculation. But it's also possible. If, for example, the concrete team makes an agreement that all fonts will be saved under concrete underscore font underscore 1, then it's okay and it can work. Yeah. The second major difference is that I/O is cleared at the end of each calculation. So these values which are saved directly to I/O structure, are valid just through one iteration. So in fact, it's equal to result holder of combi type. Yeah? When you switch to another combination, another section, another member, you step out of the context of the current calculation, you will lose all these values. Just to finish this example, in external calculation we read it very simply in this way, and the result can be seen here, very simple. Yeah, so these are three ways how you can share object values and, let's say, general common parameters between master and external calculations. Is there any question? Okay, if not, we will go to the last topic of this meeting, of this training, and these are some Dialog components, new features and things I would like to show you. The first is in the agenda on the content is the Radiobutton button. Radiobutton is a well-known component. It's available in design forms from the version, I don't know, 6.0. It works very similarly to ComboBox. You have some items which you specify here in the dialog. The difference is also in the user interface. You can attach string variable or the index variable, a numeric variable on the group Radiobutton. According to the type of variable, you receive the index of the selected component, or in fact, not the index, sorry, the numeric value. Yeah, you can specify whatever you want, for example 20 here. So the numeric value, numeric variable will receive this value. String variable will receive this text property. That's the only difference. That's all probably to Radiobutton. Other settings and properties are very similar to other well-known dialog components, so I believe you will be able to use it. Radiobutton, in my opinion, is slightly faster than ComboBox because you see directly all options and you select desired with just one click. So that's the Radiobutton. The second very simple improvement, but this can be quite useful, is this settings of the checkbox. You can switch the position of the checkbox itself to the left or the right side of the dialog. Very simple, but sometimes it's better and looks better to align checkbox on the right side. Another component which is available pretty long time but not often used is the collapsible panel. As you can see, I use 3 panels in this dialog. The collapsible panel, the main advantage is that you are able to collapse it using this plus minus sign, which can be used and looks pretty good in complex dialogs where most of settings is set only once or not so often, so it can be collapsed in default settings and it's not disturbing user. He don't have to care about this. Collapsible panel is a standard panel, this one, with collapsible property set to true. Here you can set the text which appears at the header of the panel, and also you can set different caption for the different color for the caption and for the body of the dialog. As you can see, I use not just solid color in this case. I'm using background image which allows you to use any background, whatever you want. Image must be loaded to the image library in standard way, similarly as static image used in the script. So I have 3 images here: background 1, 2, background 2, and SDF. So we can try what happens when I type SDF here. I get this background image here, which in this particular case is not very nice, but it's an option. Background image is automatically stretched to the content. So as you can see, these background images are very narrow strips, which are then stretched to the content. Yeah? So you don't have to take care about the size of the image and so on. It's automatically stretched. I would like to show you collapsible panel used in some template of refactoring basic package. Here we used collapsible panels. These are general settings which are not so often used by users, so it's collapsed in default. And then 3 another panels contains the main or the topics of the input. One more feature is here, which allows to collapse input table from the full view, which allows use copy-paste functionality of Windows to copy complete combinations from CEngineer, for example, or if he wants to type it manually, then he can switch to compact view and input just these 3 internal forces which are necessary for the calculation itself. So these are Dialog components which I wanted to show you. Is there any question to the Dialog? Or any other question to topics of today's meeting? If not, that's all from my side. I hope the meeting was recorded, so we will place it to the YouTube, and the link is available at Design Forms forum. Here, each training has its own topic, so you find all information and the link to YouTube on this site. So thank you very much for your attention, and wish you have a nice day. Bye bye.
Thanks, Peter. Bye.
Many thanks, Peter. Bye.
Thank you. Bye bye.
Thanks lots. Bye bye.
Thanks. Bye.